Let's take a look at relations and functions. Relation is just, by definition, just a set of ordered pairs. And so we've got a comparison. We've got two things that we're putting together, and so we want to then look at those and decide if they're functions. Well, in order to be a function, in order to be a function, we have to see that each domain has only one, spell it out, one range. And what that means, in terms of other ways to say it, each domain, each x value has only one y value. Other ways to say it, each input value has only one output value. And finally, the last way is the most math technical way. Each independent variable has only one dependent variable.
Max Jeffrey, please report to the main office. Max Jeffrey, please report to the main office.
Okay. So it's important for you to make sure that you understand that we're looking at each x value going to only one y, each domain only going to one range. In terms of the relations, each independent variable only has one dependent variable. And so when I look at number one here, I look at months and temperatures. So there's no x's and y's. There's nothing that technically says domain and range. There's no input technically and no output. And so I want to look more at the independent and dependent variable idea. And so then the question is, well, which one is the independent variable and which one's the dependent variable? And so I look at months and temperatures. So the question then becomes, is the month dependent on the temperature? So if I say the month is June, so it has to be 82 degrees. Or do I say that it's 82 degrees, so it has to be June? Okay. And kind of logically around that, if I say a temperature, then that temperature doesn't necessarily mean what month it's in. I mean, sometimes we're sitting in October, and October has 80-degree temperatures. Okay? That happens sometimes. Sometimes you're sitting in like April, and April has negative temperatures. Okay? It happens sometimes. So we want to look at the month has an average of high temperatures. Okay? And so the month is the independent variable, and the temperature is the dependent variable. And in this particular case, we have set numbers, so we're not just randomly picking temperatures for each month, but we're actually saying June goes to 82 degrees, July goes to 88, August goes to 93, and September has 82 again. Okay? And so we say, does each independent variable have only one dependent variable? And the answer is yes, they do. It only goes to one average high temperature. There are not two average high temperatures in the month of June. In number two, these are just ordered pairs. Okay, so I've got ordered pairs over here like -4, -3, -2, -2, and so on. Okay, so we've got nice ordered pairs. These are x's and y's, so the question is, does each x only have one y value? And when we look here, this x, or this point, this x value only has one y. And I know that because it's the only point here at -4. -4 does not have 2 points at it. Same thing with -2. -2 only has 1 point there. Same thing with 0. 0 only has 1 point. There are not 2 points at x equals 0. Same thing with 2, and same thing with 4. There are not 2 points at each of those. So the question is this a function? And the answer is yes. The part that we didn't necessarily talk about is give the domain and range. So I want to label the domain of the first one as the independent variable. Domain, independent variable, input, x value, all those mean the same thing. So the domain is June, July, August, and September. And the range is the same thing as the y's, the outputs, the dependent variables, which is the 82 degrees, the 88 degrees, the 93 degrees, and then 82 degrees again, but I don't have to repeat it, so I can stop at 93 degrees there. And then number 2, we have this bunch of ordered pairs. So I'll keep filling in these ordered pairs. This was 0, 4. This one up here is 4, 4. And this one down here is 2, -2. And so when I look at the domain and x values are synonymous. So I've got the numbers -4, -2, 0, 2, and 4. They're just the x values. The range is the y values in this case, which go from all the way down to -2 to all the way up to 4. So I have -2 and then -2 again. I have a couple points. Actually goes all the way down to -3. I missed the first point there. -4, -3. So it goes all the way down to -3, and then there's 2 at -2, but I don't have to repeat -2 twice. And then there's 2 up at the number 4 at the range of 4, the y value 4, and I don't have to repeat that twice again. So then number 3, using the vertical line test to determine whether the relation is a function. Okay, vertical line test is a test that says that if I draw a vertical line in here, that if it goes through the graph or it goes through the points at more than one place, then it is not a function. Okay? And so if I draw a vertical line in here, let me grab one from the top here quickly. If I just draw a vertical line in here, and I take that vertical line and I move it from left to right. I just had it. Move it from left to right. The question then is, do I ever cross this graph at more than one point? And so I cross it here at one point. Oh, come, I can't grab that line. There it is. I cross it here at one point. I cross it here at one point. Cross it there at one point, and I cross it there at one point. And so I do have a function because this graph only crossed it at one time. So the answer is yes, this is a function. And I move on to the next one, and I'll take this vertical line again. Then I'll go across. I touch it only at one point, one point, one point. And then all of a sudden, I'm crossed here at 3 different points on this graph. I'm crossed here, here, and here. And so because I've passed over that more than one time with my vertical line, the answer to this is no. Not a function. And if I can grab my vertical line here again, and I go across here, crossing at 1 point, crossed here at 2 points, and so again I can say no, this is not a function. And I can give a couple points that that this crosses through. It says identify 2 points a vertical line would pass through. Here's identifying these points. I don't have to write them as ordered pairs. Here are 2 points that this line would cross through. Number 6, tell whether the relation is a function. We did one like number 6 up on top, so I'm not going to do that one. Number 7, now this is a real life situation. The model car to a car's ID number. So the question is, does each model car only have one ID number? And if it does, then it's a function. If it doesn't, it's not a function. And then number 8, from the dates James took math tests to his test scores. So when James took a test, okay, if he took a test, I misread the question. I was deciding if this was a function or not. It says explain why it is a function. So you should explain why number 8 is a function. That I'm telling you that it is a function, telling you that each x value only goes to one y value, each domain only goes to one range. On the back of this sheet, this is stuff that you've done before, except that instead of us writing it this way, we used to write it this way. We said x is equal to -4, and then you needed to just plug it in. And so we're taking this information and we're just expanding on it a little bit and putting this in what's called function notation. Okay, when I have f of x or g of x or h of x, this is called function notation. And so when we have function notation, that means that you're looking at this relation and you're saying you guarantee that this is a function. If it's not a function, then you wouldn't use function notation. Okay? So when we look at it, we'll continue thinking about this as they're just saying that x is equal to -4. That's all the problem is. And so when I write this, I'm writing it as I'm plugging in that -4. And 2 times -4 is -8, minus 5, -8 minus 5 is -13. Notice that I didn't do anything on this side. Technically, this carries down, and f of 4, -4, is equal to -13. Okay? And so how that fits into a function is that they gave us the x value to be -4, and the y value then is -13. Okay? They didn't ask us for the ordered pair, but that's where we're going with this information. Okay? We're going to be using this so that we can do a better job with function notation in determining what that ordered pair is in these graphs that we're going to be looking at. Okay, so you don't need that part, but you should know about it, that it exists, and that's what we're doing with this. In number 12, we're going g of 4, so I'm using the g function where x is equal to 4. And so I've got -4 squared minus 7. The negative is out front still. 4 squared is 16. -16 minus 7 is -23. And again, this g of 4 carries down. I don't keep writing it because I don't want you at the end to divide by 4. G of 4 equals -23. And that ordered pair that creates is 4 comma -23. The input was 4, the output is -23, the x value was 4, the y value comes back to be -23. Okay, so you need that for future reference, but you don't need it right now. And so then the rest of this sheet I think is pretty self-explanatory, except for when we get to some of these letters. So I've got h of b, so I'm taking b and plugging in it for x. So that's the exact thing that it's saying. So I do the same work that I was doing before. I'm taking whatever they're telling me to plug in, and I'm plugging it in. So when I plug it into the function b squared is b squared, 3 times b is 3b, and then plus 4. Okay, this is my final answer here. B squared plus 3b plus 4 is what h of b is. Okay, I took a b and I plugged it in for the x. X is equal to b. So if I were to write this as an ordered pair, which is not something we would do, this takes us and extends a few ideas beyond linear algebra or quadratic algebra ideas. But if I were to take that, the plan, the ordered pair would be that b comma b squared plus 3b plus 4, and that doesn't make a lot of sense. So that's kind of exactly what I'm talking about with why we are not going to write it that way, but it can be thought of like that when we have answers, the x and the y. Okay? In terms of with these b's, we would say that b is the input and b squared plus 3b plus 4 is the output. Okay? An independent variable and the dependent variable. What we put in and what comes out of whatever information we're looking at. And that happens a lot in the real world. It just doesn't happen a ton in our math world.